And a happy good morning to you, pre-algebra. So I am at page 582 in your textbook. Please turn there while I go over today's joke. So what do sharks say when something is radical? Like what's a shout of something that they would say that's like, oh, that's amazing, or that kind of thing. What would a shark say? Well, they'd say that was jawsome. All right, Jossum. Shout out to my childhood and cartoons. You can look it up if you get a free chance. Anyways, page 582, we are going to be learning about something called the Pythagorean theorem. And the Pythagorean theorem is this: a squared plus b squared equals c squared. That's it. Pretty simple formula, algebra. And here's what it relates to. It relates to pyramids that are right angles. So, for example, here to my right, we have a pyramid. Did I say pyramid? Triangle. A triangle with right angles. I'm thinking three-dimensional already. I'm mixed up. That's with the other group. They're in 3D objects. You guys are still on flat stuff. All right, so it has to do with triangles that have a right angle. So here is an example. And just to give you some terminology, when we're dealing with a triangle with a right angle, we have two things called legs, two sides, and it just so happens here that our legs equal the same length. But this side diagonal that doesn't have the 90-degree angle is called a hypotenuse. So that's the terminology that I will use and that you will see in your textbook. So you want to make sure you remember that. Hypotenuse has to do with the diagonal line that does not have the 90-degree angle. Okay, so here's what it looks like. This would be A, and this one would be B, and this one would be C. So ideally, if we gave numbers to all of these sides, they should be able to complete this formula. That means the square of A plus the square of B should equal the square of C. Now, we could go into the history about how this formula came out, but we're not going to do that. So here are what the problems are going to look like. But remember this is important. A squared plus B squared equals C squared. So we can apply this only to triangles that have a right angle. So here I know that I just put numbers to this triangle. But here we have 8 millimeters and then 15 millimeters. And we need to find what is the angle of C. So knowing A squared plus B squared equals C squared, I'm going to put that in a little box up here. We're going to plug in information that we know. So we know our two legs. So we know A and B, and we need to find C. So I know 8 squared plus 15 squared needs to equal C squared. Alright, so 8 squared, 8 times 8 is 64. And then 15 squared, I gotta calculate that. 15, where's my square button? Squared, that's gonna equal 225 equals C squared. So we have 64 plus 225 is going to equal 289. Equals C squared. And I need to get C all by itself, so I need to do the opposite. And the opposite of squaring would be the square root. So I'm going to do the square root of 289. Not divide, 289. Square root, it is an even 17 equals C. And that would be our answer. C would equal 17, what? Yes, make sure we have our units, millimeters. 17 millimeters. So that is our proof, our check, using this formula. It can also apply to things that aren't automatically triangles, but that we create into triangles. So this example is coming from standardized test example number 2 on the top of page 583, and it's talking about a volleyball court. So a volleyball court is 30 feet wide and 60 feet long, and the question is, what is the distance from one corner to the other? So we're creating a triangle right there. I just laughed because I'm thinking about pyramids still. So same problem, we plug in what we know. We have 30 squared plus 60 squared equals c squared, and when you get through all the math, eventually you'll get 67.1 equal to c. So it would be 67.1 feet. That's how long of a distance it is. Okay, so we can use this to problem solve. Again, our triangles must have right angles. Very important. Okay, blank spot. So here is a real world example, and I'm just going to follow the one on this page. It says a balloon advertising the opening of a store is tethered to the ground as shown. So we've got a balloon and it's tethered to the ground, and the tether is at an angle, something like this. So here's our ground, it's tethered like that, and the information says about how many feet above the ground is the balloon. So there must be a strong wind pushing the balloon, something of that nature. So we're trying to figure out what is this. Okay, so here's the information that we see on the graph. So our rope is 40 feet long, and the distance is 25 feet from the tether to the bottom. So that's, again, all stuff that we could measure in real life. We would know how long our rope is. In real life, we could measure what's the distance so that we're right underneath the balloon. So we got to find one of our, what is it, a leg or a hypotenuse? Well, here we know our hypotenuse. Our hypotenuse is 40 feet. So let's fill in what we know. Remember, a squared plus b squared equals c squared. So here's what we know. We know a, we can do 25 squared, but we don't know b. Or you could flip it around, it doesn't matter with addition. And then, but we do know 40 feet squared. Alright, so 25 squared is equal to 625 plus b squared is equal to 40 squared, which should be 1600, I think. Yeah. Alright, so now I need to subtract 625 from each side. Remember, now we're just doing our algebra, trying to get b squared all by itself. So it's a positive 625, so I'm going to subtract it. So we just end up with b squared equals to 975. And we are going to square root each side, so that gets rid of our square. So we're going to get b is equal to 31.2 feet. So we would say that the balloon is 31.2 feet off the ground. Okay? So again, you may be doing some problem solving where there may not be an obvious triangle, but a figure or an object that you can create a triangle. Alright, last thing. We have something called the converse of the Pythagorean Theorem. What that simply means is that we're checking to see if a triangle is right, has a right angle or not. So we're just plugging in numbers to our Pythagorean theorem, but we're going to switch it around a little bit just to see if the numbers fit. So we're kind of doing a proof. We're checking to see if it's true. So here's some a sample. Some sample numbers. We have 6 centimeters, 8 centimeters, and 10 centimeters. Now, if you notice, our hypotenuse numbers are always the largest. So here we have 60, but this is 67. So that automatically means that 10 centimeters, we know, has to be our hypotenuse. So the way that we set this up is we start with our largest number. We're going to set it up with c squared equals a squared plus b squared. This is how we do the proof. So we have 10 squared. Does it equal 6 squared plus 8 squared? Alright, so 10 squared is 100, 6 squared is 36, and 8 squared doesn't equal 8, it equals 64. 36 plus 64 does equal 100, so we have 100 equals 100, so we would say yes, this is a right triangle. Now let's check out this one. Here we're going to have 6 squared. It should equal 4 squared plus 5 squared. 6 squared equals 36. 4 squared equals 16 plus 25. Uh-oh. We have a problem. Not true. 36 does not equal 41. That's not true. So if we had a triangle with these sides, we would say no, this triangle does not have a right angle. Now it still can be a triangle. All this proves is that it does not have a right angle. Remember, the Pythagorean theorem only applies to triangles with a right angle. So this this triangle with this number with the sides of this length, it still can be a triangle. It's just not a right triangle. Okay, it's a wrong triangle. No, there's no such thing. Remember, you identified triangles last time. All right, we're at 12 minutes. I'm going to cut this video off. Work hard. Problems on the board. I'll see you in real life.